Hello friends, today I am going to continue the second part of superconductivity. So today, firstly, I will discuss second part of superconductivity by starting the isotope effect. Isotope effect. What is isotope effect? In our previous video, what we have studied in our previous video. In our previous video, we have studied that superconductivity is depending upon the transition temperature Tc, transition temperature. Okay, so transition temperature varies. Transition temperature Tc depending on the material. Suppose what we have seen that in our last video, that for Hg, for mercury, transition temperature is what? Means below transition temperature, normal conductor becomes superconductor. So for mercury, transition temperature is 4.2 Kelvin. But it's not 100% sure that it will remain same for all the material. It's not that. It's not like that. So it's actually depending on the mass, isotopic mass. So how it is depending? Transition temperature is varying for different material, and it is inversely proportional to isotopic mass. M is Tc proportional to 1 by root m, where m is mass or isotopic mass. Isotopic means z value same, different a number, that isotopic mass. So this is a small thing, this is isotope effect. So let's start by discussing the London equation. Now we will discuss the London equation. It's very important thing in the superconductivity. So what is London equation? So first of all, I hope you all know the Maxwell's equation very well. Very well you all know the Maxwell's equation, that curl of E equals minus del B by del T. You all know. Hope that. Okay. So suppose if B is constant, what will be happening here? So whenever B is constant, then we will get that curl of E equals what? Curl of E equals 0 if B is constant. B is constant, then curl of E equals 0. Again we can say inverse things, vice versa thing. If E equals 0, then del B by del T equals 0. Del B by del T equals 0, it implies what? It implies that B equals constant. Yeah, it implies B equals constant. Okay, no problem. So what it means? Actually what it means? So it is meaning that we can see that whenever E is getting 0, then B equals constant, B non-zero. And whenever B is 0, then E is non-zero. Such thing. So what it is meaning that? It is meaning that from the Maxwell's equation, it is a one limitation of Maxwell equation. In case of superconductivity, we are studying the London equation. So what the Maxwell's equation, what could not prove? Maxwell's equation could not prove that E, B simultaneously can't be 0. Both can't be 0 simultaneously. Yeah. E and B can't be 0 simultaneously. Because we can see that whenever E is 0, B is becoming what? B is becoming constant. And whenever B is 0, then E is non-zero. So London assumes London's assumption. Let me clear. So what London assumed? London's assumptions were that London's assumptions was what? That there are two types of electron. One is what? one who is doing normal conductivity, that is normal electron, and second is superconducting electron or super electron, which is doing superconductivity, that is super electron. Okay, so he assumed that there are two types of electron. One is a normal electron, which is doing normal conductivity, and another is super electron. So according to the assumptions of London, normal electrons, there are two types of electrons we know, that normal electrons and super electron. Normal electron and super electron. We got that. So when these electrons exists, the existence of these electrons depends on the temperature, transition temperature. Transition temperature means what? Whenever temperature greater than equals transition temperature, that means whenever temperature greater than equals Tc, then all electrons will behave like normal electron. So whenever temperature is greater than equals Tc, that means temperature greater than equals transition temperature, then all electrons will behave like normal electron. And whenever temperature less than Tc, the temperature is whenever less than Tc, then all electrons will behave like super electron. Means below the transition temperature, all electron will behave like super electron. And not like that, all electrons behave like super electrons, not like that, sorry. Number of super electrons will increase. Number of super electron will increase. At T equals 0, all electrons are super electron. That means I am chalking out the picture, I am picturizing it. That means whenever there is a straight line, okay, it is T equals 0 Kelvin. At T equals 0 Kelvin, number of normal electrons 0 and number of super electron ns, suppose that ns equals super electrons. All super electrons, here all are super electrons. Whenever it is whenever it is reaching to the transition temperature Tc, and in the transition temperature Tc, number of super electrons increasing, and number of normal electron is decreasing. And whenever T greater than equals Tc, there is no super electron, all are normal electron. So that's the thing actually. That means according to the London, whenever temperature is greater than the transition temperature, all are normal electrons. Whenever temperature is less than transition temperature, then super electrons increasing, number of super electron increasing, and whenever T equals 0, all are super electron. So equation of motion of what we have studied here, we have studied that it is the motion of super electron at T equals 0 Kelvin and T less than transition temperature. All are T less than transition temperature, number of super electrons are increasing. So what is the equation of motion of super electron? Because we have got new things here, super electron. So there should be an equation of motion of that super electron. Equation of motion of super electron. What should be that? So in case of normal electron, what we know? In case of normal electron, we know that whenever force is existing in the field of electron, so what is the force is there? Force is F equals minus E into E vector. But in case of super electron, suppose Vs, let us assume that Vs be the velocity of the super electron. So what we can write? We can write here, whenever Vs is the velocity of super electron, we can write m dVs by dt as F equals m dV by dt equals minus E into E vector, electric field vector. Okay, we get it here. And what we know that current density of the super electron can be written as minus ns E into Vs vector. Actually, J equals NeV we all know, where Vd is the drift velocity that is a case of normal electron, but here it is a case of super electron. In case of super electron, what will be that? In case of super electron, we will write, instead of N, we will write Ns, and Q, instead of Q, we will write minus C and Vs. So we can write it here. So we can write that Vs equals minus Js into Ns into E. So here we can write m dvs by dt. In case of n dvs by dt, sorry, here one thing to correct. In case of m dvs by dt, m ddt minus Js into Ns into E equals minus E into E vector. So it can be written as djs by dt equals Ns square E vector divided by m. djs by dt equals Ns square divided by m, where Ns is the number of super electron and it is E square. E equals 1.60, that E square, and E is vector and m is the mass of the super electron. So it is the equation of motion of super electron, or we can write it London's first equation. London's first equation. This is the London's first equation. So what is the London's first equation? We are writing here djs by dt equals Ns square into E vector divided by m. So djs by dt equals Ns E square into E vector divided by m. This is London's first equation. So what we are getting it from the first equation? From the first equation we are getting that now if E equals 0, E equals 0 means what? Now djs by dt, current density of super electron equals Ns square into E vector divided by m. E equals 0. So we are getting djs by dt equals 0. It will also be 0 then. So J is equals constant. Current density of super electron is constant. So what we are getting it from here? That means whenever electric field is 0, that J is constant. Electric field is 0, then J is constant. What it means? We all know that in case of normal electron, we have all studied that J equals sigma into E vector. That is what? That is Ohm's law in case of normal electron, Ohm's law. Not that V equals IR, not that Ohm's law. We are discussing that J equals sigma E, that is also Ohm's law. But in case of super electron, we are watching what? We are saying that Ohm's law is not valid in case of superconductivity. So superconductivity, in case of superconductivity, Ohm's law doesn't exist. It's not valid actually. So we can compare here that what we have studied for the normal electron, that Jn, suppose normal electron Jn equals sigma into E vector, and if E electric field E equals 0, then Jn equals 0. And that case we are but in that case we are getting Js equals constant. For super electron, Js equals constant. So that's a different thing. Now from the first equation of London, we can derive the second equation of London also. The first equation of London was what? djs by dt equals Ns square into E vector divided by m. This is the first equation of London. And from it, doing the curl in both sides, we can derive the second equation of London. That we will do in our next video. We will discuss more about superconductivity and the London second equation. We will derive the London penetration depth also. So that is it for today. Thanks all of you for patiently watching this. Thank you. Bye.